so how do we do that with this little company of ours, and trying to be, again, make the most out of the smallest number the smallest number of parts that we could manage, and the whole thing relative to the battery was to come out with a cell box concept. So a cell box, which we also call a brick here, it's this foundational element that we said, all right, well, if we can create a box that we then give to cell companies to fill, then maybe we could use that box to create all of our batteries. So we created this cell box, this brick, and it led to 3 packs and 5 configurations of those packs that I'll talk about in a second. So it is the highest energy power density EV battery package, bar none. It continues to be that. The cell box has 28 cells in series, which gets us to our 102 volts nominal voltage. Cells are interconnected within that box, fused and instrumented, and it's a completely waterproof, watertight box. And it's, everything starts with that, with the brick, with the cell box. The module is then, a battery pack that's created with a single cell box. So we put our battery management system, our fuse, our contactor, all the peripherals that lead you from a box full of cells to an actual self-sufficient battery pack. And now we call that a module, and that's what's available on our XMX line, and that's what gives full user modularity. And I forgot to correct this slide that says patent pending. We've actually been issued a patent, and I'll mention it later, relative to what full user modularity means and what that the usability it provides. Next, we have what this thing we call the monolith, because it's the big pack, right? And we said, well, let's say if we can figure out a pack that's big enough that still fits within our motorcycle, that it can accommodate 4 of these things. So it gives us the most range, it gives us the most life, it has a single set of peripherals, so single BMS, single contactor, single fuse, that manages up to 4 of these things. So we have, for 15 model year, I should note that we work with our cell supplier to refine the chemistry specific to the SDS to get a 10% increase in range. So it's just it's not any more cells, it's just a different chemistry that allowed that. Now, the reason that we weren't able to do that for 15 model year, we weren't able to do that for the XMX, is that when in 13 model year, when we designed the cell box, the cell box had to be one thing that worked in all the platforms, and the power requirements in the XMX application, in the modular FX and military MX application, those power requirements, are much higher than they are on the SDS. So therefore, when we were able to work as we grew, and for 15 model year, we were able to work with our supplier to actually split that usage and say, hey, let's see if we can create a chemistry that's better optimized for the SDS usage and maintain the chemistry for the XMX, and that gave us another 10% in range for the SDS. So 3 brick or 3 cell box is CF 9.4, 4 cell box CF 12.5. For 14 model year, we were able to combine these 2 technologies on the SDS, or these 2 pack types, to add a power tank, basically taking one of those XMX modules and allowing its usage on SDS platform bikes to extend range even further, or give the possibility of extending range even further as an accessory for the SDS. So that's what get us to all the way to the 15.3 kilowatt hours, which is the maximum capacity that we offer in our motorcycles today. And every year, and this is something that we just believe very strongly in, that we are always looking at what we're doing and ensuring that what we're doing is the best that it can be. So every year we introduce improvements throughout the product, and especially on the powertrain, and even more especially on the battery. talk a little bit about modularity, what we mean by it, and why we think it's so cool. So if you have a vehicle with 2 or more batteries, and in the FX and military MX configuration, we have 2 of these things, and you provide or you give the user full modularity that they can, basically take these things in and out however they want. Invariably, you're going to end up at different states of charge. Invariably, you're going to take one out, charge it differently than the one that's on the vehicle, and eventually you're going to, start with 2 modules or 2 batteries that are different states of charge. If you don't do something, smart in order to manage that, that's just not going to work. So we needed to create this architecture driven by our main bike board, again, which is a master of ceremonies, to basically recognize that these things would be at a different state of charge and how to handle that. So first, on discharging, if there are different states of charge, we'll discharge from the one that's at a higher level, and then once it's even with the other one, then discharge both. Same thing for charge. If you're charging on the vehicle and both modules are there and they start at different states of charge, we'll charge the one that at a lower level until it's even with the other one, and then it goes up from there. If you never take the modules off a vehicle, then they'll always be the same. But user modularity means that you can, and it's necessary to deal with that. Again, for military applications, for police applications, for racing, this is critical, right? Coming into the pits and having an 8-hour charge time just doesn't work, right? I mean, you have to come in, you have to be able to swap these things in and out, and invariably there'll be differences of charge. The other thing I should notice, which is kind of a technical thing that we had to also overcome, is that each module is capable of 20 kilowatts peak. That's how much power you can get out of a single module. So on an MMX, which is rated, the bike that's powertrain is rated to 40 kilowatts, it's great because each of them is capable of 20, so that provides it. On the FX, which is rated at 33 kilowatts, we're still using more than the 20 kilowatts of a single module. So if you start at different states of charge and you're only drawing from one module, and you have an FX or an MMX that's capable of more power, we can't deliver that power until it's even with the other one. But once it is even with the other one, then we can deliver that. So the transition in power is important. If it's too abrupt, that doesn't work. That would be startling to the rider. So we also had to figure out how to manage that transition.